All right, so we are starting section 10.3 tonight in your book, and it's called Simplifying Radicals. So we will be taking radical expressions and writing them in a simpler form, okay? There are two properties that are at the top of page 380 in your book, in your workbook, and these two properties are the exact same thing, and I think one is supposed to be different, so I'm going to show you what I think it's supposed to be. The first one is called the multiplication property of radicals, and it's the nth root of A times the nth root of B. And what that says is that if you are multiplying two radicals together and they have the same index, then you can put them underneath one radical with that index and you can multiply them A times B. Now, I believe the second one is supposed to read the reverse of that. So I think that's just a little typo. It's supposed to say that if you have something written, A times B, underneath a radical, you can break it up into the nth root of A times the nth root of B if you need to do so to simplify. Okay? All right, so under that review and complete, number 1 in your workbook, it says radicals with the same what can be multiplied according to the multiplication property of radicals. So what has to be the same to be able to multiply radicals? What's that called? The n. What's it called? The index. So the index has to be the same in order to multiply the radicals. Okay? So using the multiplication property of radicals, there's a question, can the square root of 10 and the square root of 15 be multiplied? Could you multiply that? Now, we're not going to do it. We're just asking, can it be according to this property? And the answer is yes, because they are both have an index of what? 2. Okay? This one, the cube root of 10 times the square root of 10. Now, the way the question is worded, it says, can these two radicals be multiplied with the multiplication property of radicals? No, because this is a 3 and that's a 2. Now, there is a way to multiply these two with another property, okay, that you don't know about yet necessarily. So I just wanted to say, I'm not going to tell you that we could not somehow put those together, because we can later. But for this property, can we use this property to do it? The answer is no. Okay? In order for a radical to be in simplified form, there are 3 things that must be true. Number 1, the radicand, this is at the bottom of page 380 in your book, okay? Number 1, the radicand has no factor raised to a power greater than or equal to the index. So I could not have the cubed root of x cubed and say that that is simplified, because the radical, the index and the power are equal to each other. I also could not say that this was simplified, because the power is greater than the index. So that one reads again. It is in simplified form if the radicand has no factor raised to a power greater than or equal to the index. In other words, the powers that are under here must be less than the index. Okay? Now, I'm going to show you how to simplify these types of problems in a minute, but right now I just want to talk to you about the 3 steps that say it's in simplified form. Number 2, the radicand cannot contain a fraction. So this is not simplified because the radicand, which is what's underneath the radical, contains a fraction. Okay? So that's not considered simplified. And the last thing that is not considered simplified is if there are radicals in the denominator. Okay? So if I had 1 over the square root of 2, this is not in simplified form. So tonight, what we're going to do is we're going to learn how to simplify all these cases. Okay? Now, we're supposed to just discuss why these are not in simplified form. I don't particularly care for this problem. I'm going to throw it up here. But it says, why is this radical not simplified? Because, I don't like this problem. You're not ready for this, but I'm going to go ahead and tell you what it says. It says because 36 is a factor of this, isn't it? And 36 could be written as 6 squared. So you could actually write that as 6 squared times 10. Now, like I said, you're not ready for that yet. We're about to get into that. But that's why that's not simplified. So, generally speaking, if there's just a number under there and it's kind of big, you really need to look and see maybe if there's something that you can take the square root of that's a part of it. Okay? Again, we're going to get more into that momentarily. Why is this one not simplified? Now, we're not simplifying them yet. We're just discussing it. Because there's a fraction in the denominator. Now, this is the thing that I want to make sure you're not confused with. This one is simplified. Okay? The only thing that's in the radicand is the x. So you can have a radical in the numerator of the fraction. You just can't have it in the denominator, and you can't have a fraction, a total fraction underneath the radical. Okay? Are we good? Okay. Why is this one not simplified? Because there's a radical in the denominator. Okay? So that's why it's not simplified. Now, we're going to do a few easy ones to start with. We're supposed to simplify the square root of x squared. Now, we actually discussed this Monday night. How do I do it? Well, we kind of went through several of these. The square root of x squared is what? It's x. Do you remember why? The justification with the rational exponents? You take the power and you divide it by the what? The index. So it's power divided by index. And so the answer is x, because 2 divided by 2 is 1, and x to the first power is 1. Now, the directions say assume that x and y represent positive real numbers. So in this case, when those directions are tagged on there, you don't have to worry about absolute value signs. Okay? Which we also discussed the other night. Okay, what about the square root of x to the fourth? What about it? Okay, so we take the power and we divide it by the index. So the answer is x squared. So that was the rule that we learned Monday night, correct? What about the square root of x to the 20th? That would be x to the what? 20 divided by 2 is, excuse me, I wrote the answer. 20 divided by 2 is what? 10. Okay? Why is this true? Why is this true? I'm just going to focus on this one. It works for all of them. Because x to the 10th times x to the 10th is x to the 10 plus 10, which is x to the what? 20th. So this is your justification for why the square root of x to the 20th is x to the 10th. So it's the reverse of your power rule, basically, of your multiplication of power rule. Now, they've asked us to do we're not going to do that one right now. Okay, we're going to move on to the next example. Sometimes you will be asked to simplify one that doesn't divide evenly, or let me not say evenly, an integral number of times. Evenly, what we call it in the South. It doesn't go even, okay? Not even number, you mean it doesn't go a whole number of times. So in this case, 9 does not divide by 4 without a remainder, okay? So what you have to do is you have to break x to the 9th down into something, a power that is less than 9 that is divisible by 4. And it needs to be the biggest one, okay? So which one is the largest? What number is the largest below 9 that is divisible by 4? 8. So you will break this down into x to the 8th times x to the 1st. And I'm not going to put a 1 because we know it's there. Okay? Now, what is the 4th root of x to the 8th? So what you've done is you've broken it down into something you can take the 4th root of times something that you cannot take the 4th root of. Okay? So what is the 4th root of x to the 8th? Now, I'm not going to write this little fraction every time. You should be able to tell me what 8 divided by 4 is. 2. And then still remaining inside the 4th root is that lone little x right there. Now, what's great about this section is that they've told you consistently through it to assume that everything is positive so you don't have to worry about those absolute value bars that we learned about on Monday night. Okay? It's only when you're doing those problems and they don't say assume that it's positive. All right. Let's do another one. Let's do the cubed root of c to the 9th power. Is 9 divisible by 3? So, the answer is c to the what? Huh? 3rd. And you're finished. Okay, let's do one that's not so easy. The square root of m to the 11th. 11 is not divisible by 2 without remainder. So I need to break 11 down, or I need to go to the smallest number below 11 that is divisible by 2. The largest number below 11 that is divisible by 2. Which one is it? 10. So you're going to break it down into the square root of m to the 10th times m. Running out of room, but I think I can fit it on here. What's the square root of m to the 10th? M to the 5th, right? 10 divided by the understood 2 right there is m to the 5th. And what remains under the radical is this m right here. Okay? Sometimes they will give us problems that have many factors inside of there. So the square root of a squared, b to the 9th, c. And we're told to simplify this. You're going to use that multiplication property where it says you can take the square root of each one of them. You don't have to show that you're breaking it up like this necessarily under separate radicals. You can if you want to. Your book shows you that. But you have to know that you're doing that. And you can write them underneath one radical. So they're already written underneath one radical. This is what the property states. But again, I didn't show it up here. I left this step out. Square root of b to the 9th times the square root of c. So I could have written here on this step that I'm pointing at the 4th root of x to the 8th times the 4th root of x. I just like to do it like this. I don't like to write radicals, a bunch of radicals, so I just knew they were both under the radical. Okay? But this is the property in its purest form. Now, can you do the square root of a to the second? What is it? A. What? B to the 8th times what? B. So I could mark this off and rewrite it with that, couldn't I? So what's the square root of b to the 8th? B to the 4th. And then I still have underneath the radical a b and what? A c. And you need to put them underneath one radical. That's why I don't like to break them down, because when they get underneath separate radicals, then you have to put them back under one in your final answer. So it's just like redundant to me. I just do it here. Okay? Remember, all factors within the radicand, which is this BC here, must be raised to a power that is less than the index, and the index is 2. This was a square root problem. Okay? All right, I want you to try one by yourself. The square root of m to the 3rd, n to the 4th, p. Okay? So this would be broken down into, I can't divide 3 by 2 evenly, so it'll be m squared times m. N to the 4th I can do, so I'm just going to rewrite it. And then p I cannot do, so I'll just rewrite it. The square root of m squared is m. So if you want to mark them off as you bring them out, you can. The square root of n to the 4th is n squared. And then you're left with an mp underneath your radical. Did you put it in front? So you wouldn't, yeah, it kind of matters. It's not wrong, but I'm afraid your program might count it wrong. And you don't ever want it to look like, so you're saying you did this. Okay. So what happens is that sometimes this can look like it's underneath the radical, and it causes confusion. So we always take whatever factors are coming out, we bring them out front, and we write the radicals at the end. Okay? All right. You can use the same process for numbers. So if I wanted to do the square root of 120, and 120 is not a perfect square, but I want to write my answer in simplified radical form, then I have to think about breaking 120 down into something that is square rootable. So you need a refresher on your perfect square numbers. So 4, 9, 16, 25, 36, 49. There's some more. Which of those, if any, is a factor of 120? I know 4 divides into it. How many times? 30. And then I need to think about 30. Does 30 have a perfect square factor in it? I don't think so. It's 2 times 3 times 5, right? Okay, so what you are doing is you are breaking this number down into a perfect square factor times a non-perfect square factor. Okay? So I'm going to break this down into 4 times 30. Now, because these are numbers, I can just take the square root of 4. What is the square root of 4? 2. And then 30 just stays under your radical. This is called simplified radical form. Simplified radical form. Okay? That's the answer. This answer is said to be exact because you have not square rooted 30 with your calculator and rounded it. Okay? So this is called an exact answer, and it is called simplified radical form. The higher in your math classes you go, the more you use this in your computations.
Could we have said 120 is equal to 100 square root of 100 and that left us 20?
No, because it's not 100 times 20, that's 100 plus 20. And you're using this where you are breaking it down into where something times something can be broken down into a factor of the first something, or the square root of the first something times the square root of the second something. So it's a multiplication thing. Okay? Has to be a factor. Factors are things that are multiplied. We haven't said that since like the second class, I think. But factors are things that are multiplied. And so you are breaking it down into factors. All right? Let's do this one, the square root of 72. Now, it's very important that you always choose the largest perfect square factor of 72, the largest one. So I know 9 goes into it, but that may not be my largest one. Okay? What is the largest perfect square factor of 72? 36. Very good. So it breaks down into 36 times 2. And the square root of 36 is 6 times the square root of 2. So when you bring that out, it's multiplied times the radical. Correct? Okay. Sometimes, excuse me, you are going to have problems that have numbers and letters in it. Okay, so it's going to have 45 x to the 6th y to the 9th. Your multiplication property says that you can square root each one of these individually. And if it helps you to break it down like this, go for it. Like I said, I just usually keep them underneath one radical and put the time signs between them and break them down. Okay, so we take this one factor at a time. 45. What's a perfect square factor of 45? 9. So 9 times 5 goes under here. I can do x to the 6th, can I? Because I can take the square root of x to the 6th because 6 divided by 2 is 3. So I'm just going to leave it right now. I'll do it in a second. And then the 9 is not evenly divisible by the 2 out here. So I'm going to break it down into y to the 8th times y. Now we're going to simplify. The square root of 9 is 3 on the root of 5 times the square root of x to the 6th is x to the 3rd times the square root of y to the 8th is y to the 4th times the square root of y. And now what you're going to do, which is going to be really odd looking, okay, is you're going to put all of the things that are not under the square root in front. So 3x cubed y to the 4th. And so that, and that went out front. And then what's still underneath the square root is 5y. All right, moving on. If you have a fraction in the radicand, something like this, and you can simplify it, you should. And when I say simplify it, I mean reduce the fraction. Can you simplify that fraction? Well, sure you can. This x will divide into that x to the 7th using your subtraction rule. It says you'll have x to the 6th left. So you're going to have the square root of 4x to the 6th. So you had x to the 7th on top, x to the 1st on the bottom. The x to the 1st divided into x to the 7th. You subtracted the exponents because you used the rule for dividing like bases. And you had x to the 6th left. There was a 1 left down here in the bottom, and I don't need to put it. Now, can you take the square root of 4? It is 2. And what's the square root of x to the 6th? X to the 3rd. Okay? All right, what about this one? The square root of 200 c to the 14th over 8c to the 6th. That's one fraction underneath the radical. We know we're not supposed to have that, so we're going to simplify it if we can before we try to take the square root of it. Fraction bar means division. So is 200 divisible by 8? How many times? 25 times. 8 quarters makes $2, right? Okay, so that would divide, and you'd be left with the square root of 25. Oh, we have something weird now. I think I wrote the problem wrong. I did. This is c to the, I said 6, didn't I, in row 16? This is going to be c to the 6th. We're not ready for c to the 16th down there yet. There we go. And then c to the 14th divided by c to the 6th is c to the what power? What do you do with the 14 and the 6? And so you get c to the 8th. And then we take the square root of this if we can. The square root of 25 is 5. The square root of c to the 8th is c to the 4th. There is nothing left under the radical, just like there was nothing there. Okay. Look at 5 square root 63 over 9. And this one is nothing but numbers, but it's got some fraction stuff going on in it. So it's just an example of another problem that you might have. You really, I mean, the 9 is fine in the denominator. I don't have to think, ooh, it shouldn't be there. It should. It's fine. But that square root of 63 can simplify because 63 has a perfect square factor of what? So 9 times 7? Is that right? Y'all feel good about that? Okay, what's the square root of 9? 3. Now here's where students start getting confused. So there's a 5 out front already, and you're taking the square root of 9, which is 3. That's going to come out here. What are you going to do with that 3? Multiply. This is 5 times this radical. So anything that you bring out will be multiplied. So that will be 15 square root 7 over 9. And then you simplify the fraction parts that are outside the radical. So I can reduce the 15 and the 9. I cannot touch what's underneath the radical with those reductions. So those are both divisible by 3. So it's 5 root 7 over 3. 3 goes into 15, 5. 3 goes into 9, 3. The 7 stays. Okay? So you can only reduce outside with outside, or inside with inside. You can do that, but I can't try to divide 3 into 7. Okay? Okay, we're going to take a short break.